Tables are incredibly versatile and can be used to create various data structures such as arrays, lists, dictionaries, stacks, and queues. We will overview how to implement these data structures using tables. Arrays in Lua are tables with numerical indices starting from 1. The following example creates an array with values 1 through 5. Loops through each index of the array, and prints each element of the array during iteration. Lists are similar to arrays but are typically manipulated with functions to add or remove elements. The following snippet initializes a list with values 10, 20, and 30. Adds the value 40 to the end. Next, remove the last element from the list. Then iterates through each element. And at last it prints each value in the list during iteration. Dictionaries, or associative arrays, use non-numeric keys. The snippet create a dictionary with keys name, age, and profession and their respective values. Next, the code print the value associated with the key name, which is John. Iterates over each key value pair in the dictionary. And print each key and its corresponding value during iteration. Stacks follow the last in, first out principle. The code creates an empty table stack that will be used to store stack elements. Defines a method, push, that adds value to the end of the stack using table insert. Then defines a method, pop, that removes and returns the last element from the stack using table remove. Stack push adds 10 and 20 to the stack. At the end, print 20 and 10, respectively, showing the behavior of the stack. Queues operate on the first in, first out principle. The snippets start creating an empty table queue to represent the queue. Defines a method enqueue that adds value to the end of the queue using table insert. Next, defines a method dequeue that removes and returns the first element from the queue using table remove, which operates with an index of 1 to ensure first in, first out behavior. Next snippet creates simple inventory system. The system should support the following operations: adding an item, removing an item, and listing all items. It starts by creating an empty table inventory that will be used to store items. Defines a method, add item, for the inventory table with parameters name and quantity. Then checks if the item already exists in the inventory. If item exists, increments the existing quantity of the item. If item does not exist, adds the item to the inventory with the specified quantity. In summary, this block of code allows you to add items to the inventory either by updating the quantity if the item already exists or by initializing it with the given quantity if it's new. The following function defines a method for the inventory table. It takes two parameters, name and quantity. Next checks if the item name exists in the inventory. Subtracts the specified quantity from the item's current quantity. If the updated quantity is 0 or less, it removes the item from the inventory by setting its value to nil. If item does not exist, prints an error message indicating that the item was not found in the inventory. In summary, this function removes a specified quantity of an item from the inventory. If the quantity drops to 0 or below, the item is deleted from the inventory. If the item does not exist, an error message is printed. Next function defines a method list items for the inventory table. This method is used to list all items and their quantities in the inventory. Then uses pairs, self, to iterate over all key value pairs in the inventory table. Here, name represents the item name and quantity represents its quantity. It checks if the quantity is of type number to ensure it is a valid inventory item. If true, it prints the item name and its quantity. The last part of the code provides a way to display the current inventory, showing each item and its corresponding quantity. We have explored using Lua Tables to implement various data structures including arrays, lists, dictionaries, stacks, and queues. We applied these concepts to design and manage a simple inventory system, demonstrating how to add, remove, and list items effectively. Additionally, we covered techniques for manipulating tables, such as iterating over elements and defining functions for specific operations. This comprehensive approach provides a solid foundation for managing data and building applications in Lua.